Hello everyone, welcome to this session on Android application security analysis. In this video, we will perform the detailed static analysis of an Android APK using MobSF. So, static analysis means we analyze the application without installing it or executing it. So, the application we are analyzing today is called Fireview application, and which is intentionally made as a vulnerable so that student can test this application. Student or any other person can test this application. So we will go through each session section of the MobSF report and understand what it represents and what are the security risks and discuss why these findings matter from the security perspective. So first we begin with what is a MobSF and how we are using it. The MobSF is simply stand for a mobile security framework, which is an open source application. It is an automated tool which is used for Android or and iOS application security testing. But in this video, we mainly focus on Android application. So MobSF can perform static analysis, dynamic analysis, malware check, and security configuration review. So it can be used in two ways. First one is installing it locally, and another way is by using the online instance, which is available at mobsf.live. If you simply type a mobsf.live, then it will open the same window like this. But only difference is you can locally test the application, and on the mobsf.live, there you need to upload the application. Is same like this, but it will be accessible to other user as well. Not user, other user of a MobSF. So in this demonstration, I'm using the locally installed MobSF to analyze the FireView application. So first we begin with upload and analysis. Here we can see a simple button. So when we click on this, then here I have a couple of applications. So I'm selecting this FireView application. So once I select the application, it will take a time, and it will automatically, MobSF automatically decompile the application, which extract the metadata, analyze the source code, and generate a detailed static analysis report. So no execution of the application is required for this analysis. So here, first one we can see a app score. So this section is the show overall security score of the application, and the score is a calculate based on various things like a code issues, manifest misconfiguration, exposed component, and security best practices. A lower security score indicates the higher security risk, and this score help security team to quickly access the whether the application is ready to release or not. So like with the help of this, we can only say it's 40 out of 100. So it might have a issue. Some security configuration is missing. So we can check whether an application is ready for release or not with the help of this app score. So here we can, at right side, we can see the file information. The file information is simply like a section provide the cryptographic detail about the application. Like this include the file size, then MD5 hash, then SHA-1 hash, SHA-256 hash. Like these value are used to verify the app integrity. Like we can detect the tampering, and basically it's like a unique identity of application. We can uniquely identify the application with the help of this. So here we can see the exported activities, then exported services, receivers, and providers. Here we only have a count of it. Then below we can see the decompile code. The code is decompiled into three things. First one is Android manifest.xml, view source, and view small code. Then here we'll get access to the whole code. But like in this video, only we will analyze with the help of this code only. The MobSF analyze with the help of this code only. So here we can see the signed certificate. So this certificate section like analyze the how the APK is signed. The Android application must sign before the installation. Um, MobSF check the security validity, then signature skim version, potential vulnerability, and a weak or outdated sign-in scheme can expose the application to secure to signature-based attack. So this information is very helpful. We can see like a V1 signature, V2 signature. Like this, we have a serial number, which hash algorithm is using, and likewise we can see like a public key algorithm, RSA algorithm. All those like cryptographic information we'll get from this section. Then another section is application permission. So in this section, we MobSF lists all the permission requested by the firewall application. Permission are categorized as a normal, dangerous, or special. So excessive permission increase the attack surface. The developer should follow the principle of a least privilege, means requesting only what is strictly required. So in this way, we can handle the permission section. So it's up to developer like which permission we need to enable or we want and which permission we don't want. So here is the Android API. Like a MobSF analyze all the Android API used in the application. Like this help to identify the uses of a sensitive API, cryptographic API. Then another one we have a storage API, network API. Like each API is a link to the file where it appears. Like here we can see show the file section. So then browsable activity. Here we can see like no data available in a table, but I can like give us some information about browsable activity. Means browsable activities allow the application to respond to the external links. When a user click a URL, then Android decides which activity should open. And if browsable activity are misconfigured, then attacker can redirect user to malicious screen. So it quite risky. So attacker get redirect the attackers can redirect the user to malicious screen. So MobSF list all the browsable activity for the security review. Browsable activity is simply like activities which allow an application to respond to external links. So next one is a network secret. Like since we don't have a data available in a table. So in this section, the network security configuration in this session means control how our application communicate with the network over the network. It defines the rules for HTTPS uses, clear text traffic, and trusted certificate. The weak network configuration can expose the data to man-in-middle attack. So here is certificate analysis. So certificate analysis is a focus on a TLS and SSL trust setting. The MobSF check whether insecure certificate are trusted, certificate pinning is a missing or weak encryption is a use. Those things checked by the MobSF. Improper certificate handling allows the attacker to intercept the encrypted traffic. So this one we need to careful. So in manifest analysis, the Android manifest.xml file define the core behavior of the application. The MobSF highlights the high severity issues such as debug mode and enable. So we can see like a debug mode enable. Like when the debug mode enable, which allows the runtime inspection. So another one is allow backup, which is a true, which is a enable, which allows the data extraction using the ADB. So here we'll get information like in description section debugging was enabled on the application which make it easier for reverse engineering to hook debugger to it. So simply it is a quite risky. That's why we can see like it is in high severity. So these issues are significantly increasing the risk of a reverse engineering and data leakage. So here we can see like a Stranghawk 2.0. So in Stranghawk, basically, Stranghawk is a CV, which is a critical security vulnerability in the Android operating system. Disclosed in May 2020 that allows the malicious app to hijack the legitimate application and steal the user data without requiring the root access. So this activity is vulnerable to Strandhawk 2.0 vulnerability. So, so we need to careful. That's why it's in the highest status. So here also the activity is vulnerable to Strandhawk 2.0. Same here. So this is all about Android.manifest file. Like it defines the core behavior of the application. Then next section is code analysis. So I will give a intro about what is a code analysis. The code analysis is a section which inspect the Java and Kotlin source code. And MobSF identify the issues like insecure cryptography, hard-coded credential, then weak random number generation, insecure file handling. Each issue include the like here we can see the standards. Like we can see what are the CV. Then we simply search the CV on Google. Then we'll get all the idea about this. Then we can see the which file contains this. Likewise, we'll get all the information in code analysis section. Then another section is shared library binary analysis. So here no data is available. So in this session, analyze like a native libraries used by the application. So native libraries means it runs at a low level and which are harder to secure. So suppose I will give an example like what are the native codes. Suppose if you have an application called the PDF scanner application, which is XYZ application, which is the purpose is to scan the PDF or to pre-process the image. We have an application which pre-process the image, and in that application we use one filter called Gaussian filter. So we have a native code available for this Gaussian filter. So basically the native code which is run at a low level and harder to secure. So MobSF check the third party libraries, architecture compatibility and no binary vulnerabilities. So vulnerable libraries should be updated or replaced because it is quite risky. So then we have a next important section is a Firebase database analysis. So this is a very important section. Like this section check like a Firebase database uses. MobSF verify like whether our Firebase is used, if authentication is enforced, and if security rules are configured. Like it verifies only. And if Firebase is a publicly accessible, anyone can read or modify data, then this is a critical issue. So we need to check like the here we can see a title like Open Firebase Database. The Firebase database is at this is a URL and is exposed to internet without any authentication. Means with the help of this, anyone can modify data, anyone can read the data, any personal information can be still by attacker like this. With the help of this, quite a risky and very important section, Firebase database analysis. So another one is here we saw the what is the behavior analysis? Let's come to behavior analysis, like which examine the how the application is expected to behave. So it only identify the suspicious actions such as excessive permissions. Then here we can see like a behavior, read a file and put it into a stream. So it defines the suspicious actions such as excessive permission, hidden communication, abnormal API uses. So it help to detect the potential malicious intent of a attacker. Then what is abuse permission? So abuse permission are permission which commonly misused by the malware. So example include the internet access, storage access or device access. We can say device state access. So MobSF highlight this so the developer can review and take a necessary action. Here are the server locations. So in server location we can see like what are the servers location and United States, then again United States of America. So we'll get idea like what are the servers location with the help of simple map we can see. Another section is a domain malware check. So this section check all the domains contacted by the application. Then MobSF verifies whether any domain is associated with a malware or botnets or any phishing sites like this. Then suspicious domain must be blocked or removed. So here all the status is okay. Okay, so here we'll get an idea from this table only. Only like which are suspicious things and which is not. So according to this way, the user can identify. Then URL analysis. MobSF extract all the URL found in the APK file. So this help like to identify the hard-coded endpoints. Another one is test servers, outdated links. So if unnecessary URL is there, then it should be the remove. So from this section also we'll get all the URLs. Then another one is email analysis. So this section lists all the email addresses found in the APK. Then hard-coded email, like suppose in APK file we have a hard-coded email like abc at the rate xyz.com. So so we'll get all those emails from a APK file and which is not like a good part. So here we can see like abc at the rate gmail.com. But this firewall application is intentionally made as a vulnerable application. That's why it's showing. But suppose if any application, any finance application, or any and like any Android application, which is a which is a famous. So here we'll get a like any email list of email. Then attacker can use those emails and it uses in a wrong way. So this is a also we can check. Then another one is a tracker analysis. The tracker are used for the analytics. Then we have an ad section. Then performance monitoring also. So MobSF list all the detected trackers. So developer must ensure like a privacy and user consent for this. So the next important section is a possible hard-coded secret. So we can the Firebase database URL, then Google API key. Then because key is there exposed in this report, so this is a very risky thing. Like anyone can extract data, anyone can steal important information from the application. So here we can see password string. So the MobSF scan for the hard-coded secret, and this include like we can say API keys, password, tokens, and another one is saying is a cryptographic keys also. Then hard-coded secret are like a serious security risk and must never be represented in a production application because this thing is very risky. Then here is showing all 31 version package. Okay. Then SBOM. What is SBOM? The SBOM stand for a software bill of material. So it lists all the components, libraries, dependencies used in an application. So it helps to organization to track a vulnerability, manage supply chain risk, then comply with security standard. Even if no what we can no security bill of material is present, like a SBOM is in, if no SBOM is present, understanding is important for the modern application security. So, so conclusion of this report, like To conclude, the MobSF provides a comprehensive view of Android application security, and which is a open source, which is a very special thing about MobSF, which is a open source. So by performing a static analysis early, the developer can identify and fix the vulnerability before releasing the application. So that's it. Like this is a whole information regarding the static analysis. So thank you for watching.